So, if you look at my web page, let me get to it here. All right, if you go down here, so that's the first module, and by next week you should do some quizzes on Chapter 1 and Chapter 2. So read the first couple chapters and do some quizzes, and you just start doing the hands-on projects. And the first thing is binary games. The projects are here, and here's the binary games. You got to learn binary. You're going to do forensics. You have to get down to raw data. So let's just talk about nibbles. And what I recommend is just do one of these per day. I'll demonstrate one every week if I can remember, just so, because if you do this in small bites, small pieces, it's much easier to learn. The most common mistake in teaching math of all kinds is you teach too much math in one lesson to where people get confused. If you just do one step at a time, it's simple. If you can count on your fingers, you can do math. It doesn't get any harder than that, as long as you don't make it confusing, which is what typically happens. A lot of my students are afraid of math, but you don't need to be. So in base 10, these are the numbers we use all the time. If I write down 147, you know that the 1 means that's the number of hundreds, and the 4 means that's the number of tens, and the 7 is the number of ones. Now you can express that as 10 to the 0 for 1, and 10 to the 1 for 10, and 10 to the 2 for 100. That's another way to express those numbers. So we're used to this. You have the hundreds place, the tens place, and the ones place as you write down a 3-digit number. Now in base 2, which is what computers use, you don't have 10 symbols, you only have 2, 0 and 1. That's it. So if you want to write down 3, it takes a 2-digit number, 1, 1, which means 1, 2, and 1, 1. And so you have, instead of ones, tens, and hundreds, you have ones, twos, and fours. So this number, 101, is 5. It means you have 1, 4, no 2s, and 1, 1. And so you can count. With 3-digit numbers, you can count up to 7. 0, 1, a 2 is 1, 0, and 3 is 1, 1. That means 2 plus 1. 4 is a 3-digit number, 1, 0, 0. That means 1, 4, no 2s, and no 1s. And the biggest number you can write with 3 digits is 1, 1, 1, which is 7. That's 4 plus 2 plus 1. So it takes a little getting used to, but that's how it works. And nibbles are 4-bit numbers, half of a byte. So you have 1s, 2s, 4s, and 8s. So this number is 9. You have 1, 8, no 4s or 2s, and 1, 1, so it's an 8 plus 1, that's 9. It takes 4 digits to write down 9 in base 2. And here are all the nibbles. So you see the highest possible nibble is 15, 8 plus 4 plus 2 plus 1. This one, 10, 10 is 10. That's 8 plus 2 for 10. And here's 9. Another thing to notice is even numbers remain even in base 2. All the even numbers end in 0. All the odd numbers end in 1. Because this is 1, 2s, 4s, and 8s, any number of 2s, 4s, and 8s will always be even. The only way to have an odd number is to end in 1. So learning how to convert base 2 to base 10 is a really important skill, and this is where it starts, with nibbles. So for the hands-on project, you do a little game here. You have to get 10 in a row right to get a flag. So we'll do a few of them. So here, what is that number in decimal? 1, 1.
3.
All right, it's 3. That's correct. How about this one? That's 1, right? Just 1 is 1. How about that one?
15.
You're right, that's 15. That's 8 plus 4 plus 2 plus 1. So you have to get them, and when you get 10 in a row correct, you'll get a flag here. And when you get a flag, you just, let me bring up the, all right, when you get 10 correct, then you capture the flag, take a screenshot of it, and turn it in. There should be instructions somewhere telling you how to do it. I guess I'll have to add it back to this page. But you take the screenshot and flag and you turn them in Canvas. Go look in Canvas and you'll find a place to turn in the binary games. So you put in a screenshot of this showing you the flag here. After you get enough right, a flag will appear. That's how you turn it in. And if you people are used to capture the flag contests, I'll add a automated score you can put in here too. but I haven't got it in here yet. So I'll talk more about that next time. Anyway, that's the first hands-on project, what you should start doing. And after that, you need to get a Windows machine. So either a cloud server on Azure or a Windows virtual machine, or if you have a Windows laptop you want to use, you can use that too. What we're using here, I'm not doing anything very dangerous in this class. You could use a real machine. But you need to get some kind of Windows machine going because the main thing we're going to use is Autopsy. Autopsy is Windows-based forensic software. It's the open source clone of like EnCase and FTK, sort of like OpenOffice is an imitation of Microsoft Office. It gives you a lot of the functionality for free so we can practice using it. And we'll use that to examine all kinds of evidence, network evidence, evidences from computers and from iPhones and so on, to practice finding evidence from various devices. So the first homework is just practice some binary, and the next homework is get some kind of Windows machine running. And that's all the homework that's due for the first couple of weeks. So let me take a look for questions in the chat here. People tell them where to find it. Good. Can't find a link. Is this on Canvas? You start at samsclass.info. I see other people are answering good things. That's in chat. Good. All right. I'm going to stop the recording.